Hello. Today we are going to be doing what was your group quiz, but it is from 2024. Paper 1-2, May, June. If you don't know how to read those, that's how you read them. May, June 2024, Paper 1, Version 2. Which could be found on Papa Cambridge with answer keys, but I crossed them off on your group quiz. We are going to be doing numbers 5, 6, 10, 12, all the ones that you see in front of you. Those are the ones that we are doing. If there is a problem that you did not see there, don't watch this video because you won't be there. Number 5, we have a diagram that shows a laboratory experiment with a vacuum and a feather. And originally it was dropped and it was able to fall the whole length of the tube. And then we want to know how far it would have gone if it was half of the time. Okay? Based on the fact that it is half the time, delta y is equal to 1/2 gt squared, because it was just dropped. And if it's in a vacuum, there is no air resistance. That's the only reason that we talked about the vacuum. And if it wasn't in a vacuum, feather has a lot of air resistance. We have half of the time. If you recognize that delta y is proportional to t squared, because gravity and 1/2 never change, if you plug in a half for time, you would get a delta y that would be 1/2 squared, which is 0.25 or 1/4. That is awful, 1/4. 1/4. And that is 1/4 the length. Another way you could think about it is it started out really slow and then it sped up the longer it fell, which means that it would not go half the length. It would have to be something smaller than that, which really only rules out part D. Number 6. In order to get from a velocity versus time graph to a position versus time graph, if you go backwards, you have to find the area. Okay? So if we have to find the area, that is all you're expected to do from here to here. The trick is that you don't put a base of 4, you put a base of 3, because from 1 to 4 is 3, not 4. I've made that mistake in the past. Then you just have to do an area problem where we have 1/2 the area of the base and the height of the triangle, which would be 10 tall and 3 wide. So 1/2 base times height for the triangle, and then the rectangle would be plus 3 times 10. And if you do those, you end up with, I believe, 45. The next one we're doing is jumping all the way to number 10. Number 10. 10, I got wrong a few times before I got it right. I was just struggling with number 10 as well, so no shame there. It was a harder question in the sense that you had to start with momentum. We have to start with mv is equal to m plus m, v final, and then use energy. So it was a twofer. And you had the conversion with 95 grams and 5 grams. I think that's where I struggled somehow. It started with the 5-gram pellet, which would be 0.05. I'm asking for not 0.005. Yeah, same mistake. 0.005 kilograms. And it was going quite fast. It was like a bullet going 200 meters per second. And then that would equal 0.005 plus 0.095 for 95 grams V final. You solve for V final, which is either 10 or 100 or 1. It's something like that. I got 10 for the V final when you solve for that. So once you get the V final is 10 meters per second, then you're like, okay, now how high will the ball that's embedded in this clay block actually fly up into the air? You would just be turning kinetic into potential. The mass would be the combined mass, not the mass of the little ball or the clay, but the combined mass, but it doesn't really matter because it cancels. You get 1/2 of 10 squared is equal to 9.81 times height. You solve for height, you get 50 divided by 10 essentially. That leaves roughly 5, but apparently if we use 9.81, you get 5.6 or 5.1? 5.1. Should have known that. 50 divided by 10 is closer to 5 than 5.6. Yeah, that was a little bit extra. There were some of these that were way harder than you would think. Next one on the docket is number 12. Number 12 is a torque question, which for some of us is our nemesis, especially if it's presented like this. So, We got perpendicular. Always make the force that is provided the hypotenuse of your triangle. And we got perpendicular again. So that means that this is the opposite side, and this is also the opposite side of the 60 that could kind of transpose down to there. So both of those are opposite. And because one is pulling up and the other is pulling down, they're going to be counteracting each other to the point where they're in equilibrium. So we have force, sine of 30, because it's opposite, times a full length or radius away must be equal to the force, which is 3 for the other one, sine of 60, times not a full radius, but half the radius, so L over 2. And at that point, you might be thinking, oh no, I got two variables, but the L's cancel. And then we're solving for force, so we would have force is equal to 3 sine of 60 divided by 2, because you had the 1/2 there. And then you're also dividing by sine of 30. If you get confused by doing it that way, do it separately. Just type in 3 sine 60 divided by 2, and then just divide by sine 30. And if you do that, you get 2.6. Also make sure you're in degree mode, not radian mode. I don't know how you guys didn't pick 13. 13 was the hardest one. I think we already did 13, though. I have seen a question like number 13 twice total. You picked 13? Well, that's just fantastic. 13 is hard. Let's do 13. All right. Density is mass divided by volume. We got to use that equation twice in itself. So we need to understand that we have the combination of the mass of water and the mass of glycerin added together, divided by the volume total. We want that to be a density of 1.1 with the mixture between the glycerin and the water. The part that really upset me on this one is it said, assume that the volume of water and glycerin does not change, when that is not true. It will definitely change. And I don't exactly know what they meant by that, but maybe it's like, maybe the total amount that you had on hand doesn't change. I guess. Maybe it doesn't react. That kind of makes sense. Anywho, we can get the mass of water by doing the density of water times the volume of water. So that part right here can be replaced. And then we can do the same thing with mass of glycerin, and volume total. We'll have to add the two volumes up. We started with 40 centimeters cubed, which I will not be converting into meters cubed, of glycerin. All right, so that is going to be what I plug in for the mass of glycerin and the volume of glycerin. So we got 40 total of glycerin. That's the volume of glycerin. We got a mass of glycerin. If there is 40 volumes of it and each one weighs 1.3, you would have to do density of glycerin, volume of glycerin. So that'd be 40 for the volume and 1.3 for the density. That would be the mass of the glycerin. We could add that to the density of water times the volume of water. And on the bottom, to get the volume total, we would have to add the volume of water in. That is what needs to equal 1.1. Which is also kind of like awful. Like that. Thinking of how to do that is rough. There are other ways to do it too, but I don't remember how to do that. I knew how to do them like 7 years ago. With just like basic algebra 2 like mixture problems, which were awful then too. If you solve for volume of water here, you get 80 centimeters cubed. Another way you could do it is just logic your way through it a little bit. You had 40. You want it to be closer to the water than to the glycerin, so you should probably add more water than you had glycerin to make it closer to the water density. All right. 14. You guys pick good ones. Power is force times velocity. Power is what we're looking for. Force times the velocity we are currently going is 40. We need to figure out what is the force that we will have to use from the engine to be able to be going 40 meters per second. And they tell us that the force of air resistance is proportional to the square of the speed. So if the force of drag is proportional to the speed squared, that means that the force of drag, when it was originally, 800? When we were going 20 meters per second, if we jump up to 40 meters per second, we have doubled the speed. And if you double the speed, the force of drag would be 2 squared, or 4 times what it was before. So 4 times 800 is 3,200. That part can get plugged in for the force. You multiply 3,240, you get 128. Questions with that? We are getting close. 16 is the next one. The kinetic energy of a particle increased by a factor of 4. What factor does the speed increase? Well, kinetic energy is equal to 1/2 mv squared. The 1/2 and the m don't matter. Kinetic energy is proportional to v squared. If you quadrupled the kinetic energy, and it is proportional to v squared, you could square root to get what the v would turn into, which would be the square root of 4, and that would be twice the kinetic energy compared to what it was before. They had a lot of these proportional things on this go-around. 18 is next. 18. I do not want you to memorize this answer. This answer is not normal. Typically, this is the elastic region. Typically, this part, at least where it starts curving, is the plastic region. I thought that that was also linear and therefore followed Hooke's law, and I said both. However, if you read very carefully, this problem is unique in the sense that it says that the sample contracts and follows the exact same force extension curve as before, which means that it was able to go back to its original slinky metal wire position. Normally, once you stop obeying Hooke's law, it will not go back that way, and it'll kind of do this number. All right? So this is an atypical problem. It is not normal because it did go back. This upgrades, I guess, from plastic to elastic because it is going back the exact same way in which it came. I don't like the problem because it kind of teaches you the wrong thing for the majority of problems. Oh well. 19? 19. I did not do 19 fully. I did do 19 enough to get my answer, though. You got a Young modulus question, I believe, where you got force divided by areas divided by change in length over original length. The key here is area is affecting it, and we're extending it, and we got a force. I believe it's probably just the force over area problem. And we want to compare the diameters, so you can think more than do on this question. If it takes more effort to extend like less, so we pull for 2 newtons and it only goes to 1 millimeter versus the other guy pulled for 2 newtons and it got to 3 millimeters, Q has got to be a bigger, thicker wire because it would be harder to move. And that means that we have a bigger value over a smaller value. Anytime you have a bigger value over a smaller value, you can rule out the things that don't do that. And then you're left with either 3 or square root of 3. If you look at the slopes, we got 3 versus 1, which may make you believe it's D. It is not D because it's area, and they're comparing diameters. And diameter squared is proportional to the area. It's pi r squared. And because of that, that is why it's square root of 3 times more force, or I don't even know what we're comparing, diameter. What next? 19 done, 20. We're moving right to the same things. Conversion, but be careful because this is in centimeter, this is in meter. It could be centimeter to centimeter. Don't assume that it's going to need to be converted. You got force of a spring is equal to kx. I'm betting it asked for the spring constant. That is the k. The force was 6. K. The x is 15 times 10 to the negative 2 for centimeters, and then you just divide. And when you divide, you get a number, And that number I got was 40. 21. When is the Doppler effect going to have the highest frequency? Well, it goes from high when it's approaching to low when it is leaving. So we know it is going to be something to where it is approaching and not moving away. Okay? I disagree with these and that because it's at point X and at point Z, it's actually switching from like moving away to moving towards and vice versa. It's also actually at point X and Z has zero speed. And if it's not moving away or towards, there is no Doppler effect. There's also no Doppler effect the moment, or at least no bending or distortion of frequency the moment it is passing you. When it's switching from E to O, like that blip where it is passing you, same exact frequency as regular. If you could get that split moment. So it is moving the fastest at Y, and it is moving towards when it is having a high frequency. 21, oh, we didn't even have to do 21. Oh, there it is, found it. 23. Yeah, smiley face. 23 is a doozy, to say the least. It was maybe my least favorite problem. It probably wasn't. It was close. If you read very carefully through here, it says like point X, it falls to a minimum, then rises again to a maximum at point Y. Actually, it's maximum, minimum, and max. So if it's at a maximum at point X and a maximum at point Y, that means that it is kind of like that X and Y, which means that between X and Y is a full wavelength. You had to read between the lines to find out that this is your lambda. Then you had to go further and think speed is equal to wavelength times frequency. 330 is equal to wavelength, 33 times 10 to the negative 2, a conversion on top of that, times frequency. We need the frequency in order to figure out anything with a CRO machine besides amplitude or intensity, because amplitude squared is intensity. You get frequency. The frequency of this, hopefully I got it stored on my paper, is 1,000? Okay. I got 500. If the frequency is 1,000, the period is 1 over frequency, so the period is going to be 1 over 1,000. Then you have to think which one of these completes a full cycle in 0.001 seconds, which I believe is B. When we count up this, it goes 1, 2, 3, 4. We're done with a single cycle. And each of those represented 0.5 milliseconds. And if you add up 0.5 4 times, 0.5 times 4 is equal to 2 milliseconds. You sure it's not? You sure it's 1,000?
Well, we convert it to meters, but on the actual thing it's centimeters. I don't know if that makes any sense. You have to convert it back.
Okay. So it's still B with that? I did a wavelength of 33 centimeters the first go around.
Yeah, because the actual graph is in centimeters.
Yeah. Well, like my first time I did it, I didn't interpret the 33 as a full wavelength. I interpreted the 33 as a half a wavelength. Does it work out with the 1,000th part? Because 2 milliseconds is not that. Well, like 2 and 1. Agree? Yeah, if in fact the wavelength is 33, then it would have been this one because that is 0.5 times 2, which makes 1 millisecond for the full period. Maybe I read wrong the second time. Zero rises to a maximum at X, falls to a minimum, then rises once again to a maximum at position Y. The distance between X and Y is 33. Speed of sound is that.
Oh, you multiplied 2 times 0.5 times 10 to the negative 3
Yeah.
on my paper, and then you got 0.001.
I might have to come back and look at that one in a bit. pausing on that one. We got 28 and 30. 28 and 30. At which would be the same separation of x. So the regular formula is d y max over L is equal to m lambda. We want, if you read it, the y maxes to be the same. The slit separation does not change, so I'm not going to pay attention to that. The m value does not change, so I'm not going to pay attention to that. The y max is going to be equal to wavelength times the distance away from the wall. Okay? Because we want the y maxes to be the same, that means that wavelength initial, length initial must equal wavelength final, length final. You could just set them equal to each other because we want them to have the same pattern on the wall. We plug in the 600 for the initials and the 1 meter for the length, and then the 400 for the final, and you solve for length. Technically, the 600 is times 10 to the negative 9 for nano. However, the 10 to the negative 9 part cancels out. You're really just doing 600 divided by 400, which gets a 1.5 for the length. The last one is 30. I like 30. It's a circuit question. You don't like 30, eh? The reading on X is 4 amps when the switch is open. After we close the switch, you have added a resistor in parallel. Anytime you add a resistor in parallel, the overall resistance total will go down. If resistance goes down, then because current is equal to voltage divided by resistance, if resistance goes down, current goes up. So the current on resistor X, not resistor X, but on ammeter X will increase. That rules out A and B, because originally it was 4 amps. The current going through the ammeter Y, well, we know that it's going to be 6 total because we can read, and it says 6 total going in. And that 6 is going to have to split up to here and here. Where is the current of 6 total going to want to go more? Is it going to want to go to the little guy or the bigger guy? Well, it's going to want to go to the little guy. So this is going to be 4 amps over here, and this will be 2 amps down low, because it's going to get more on the top and less on the bottom, and that makes it C because we want 2 to go through the bottom strand. All right. That is going to do it for this one. I'm going to have to relook at the CRO. If I get anything quickly, I might do a different video, but I doubt it. Bye.